The Caterpillar D11, one of the largest and most powerful bulldozers in the world, stands as a symbol of Caterpillar's dominance in the heavy machinery industry. It represents decades of engineering expertise, technological innovation, and Caterpillar's commitment to providing powerful machines for the toughest earth-moving jobs. But how exactly is this giant built? Let's explore in detail how Caterpillar crafts this behemoth from raw materials to its final form, ready to conquer the toughest terrains. Before the D11 can be built, there is a comprehensive design and planning phase. Caterpillar's design team relies on both traditional engineering principles and cutting-edge technologies to ensure that the D11 is not only powerful, but also efficient and safe. The development of any new bulldozer model, especially something as large and complex as the D11, begins with research. Caterpillar's engineers gather data from the field, examining how existing models perform under various conditions. They analyze customer feedback to understand which features need improvement and what new capabilities might be beneficial. For example, operators might need better visibility from the cab, increased power, or more durable components. In the case of the D11, the feedback emphasized increasing durability for long work hours in mining and construction, better fuel efficiency, and stronger materials to handle extreme tasks. Once the research is done, engineers begin designing the D11 using advanced CAD software. The D11 is a highly intricate machine consisting of thousands of components that must fit together perfectly. Engineers use simulations to test various parts before they are ever physically built. This process allows them to optimize the design for strength, weight distribution, and efficiency. Engineers can simulate how the bulldozer will perform in different environments, whether it's operating in a desert, on rocky terrain, or in a muddy construction site. The CAD software also allows engineers to conduct virtual stress tests, evaluating how components like the frame, engine, and hydraulic system will behave under the intense forces they will encounter in the field. After finalizing the digital design, the blueprints are sent to Caterpillar's production plants, where the physical creation of the D11 begins. The manufacturing process starts with raw materials, particularly high-grade steel. The choice of steel is critical because it ensures the bulldozer can withstand the immense stresses of pushing and ripping through earth and rock. Caterpillar sources high-quality steel from suppliers around the globe, making sure the material meets their stringent standards. The first step is to cut the steel into the shapes needed for the D11's frame and components. Huge sheets and blocks of steel arrive at the manufacturing plant and are cut using CNC computer numerical control machines and plasma cutters. These machines are programmed with precise measurements to ensure that every cut is accurate. For the D11, this is especially important, as even slight deviations can affect the bulldozer's structural integrity. Plasma cutting allows for highly accurate cuts through thick steel, a necessity when building a machine as massive as the D11. Once the steel is cut, the pieces are welded together to form the D11's mainframe. Caterpillar uses a combination of automated robotic welders and skilled human welders to ensure the welds are strong and consistent. Automated robots handle the bulk of the work because they can produce uniform, high-quality welds at a faster rate than human workers. However, human welders are often employed to handle more complex welds or to work on areas that require greater finesse. The frame is the most critical part of the bulldozer because it holds all the major components together, including the engine, transmission, and hydraulic systems. After welding, the frame undergoes non-destructive testing, such as ultrasound and X-ray inspections, to check for internal defects or weak points in the metal. Caterpillar's commitment to quality ensures that every frame can endure the enormous forces it will encounter in the field. The engine is the heart of the D11, providing the power that allows it to move mountains of earth. Caterpillar designs and builds its own engines, and the D11 is typically fitted with a Cat C32 engine, a massive 32-liter V12 diesel engine that produces up to 935 horsepower. This engine is not only powerful but also engineered for durability and fuel efficiency, enabling the D11 to perform long shifts in harsh environments. The engine's components like the pistons, cylinder heads, crankshafts, and turbochargers are crafted with precision. The manufacturing process begins with casting, where molten metal is poured into molds to create the engine block. Caterpillar uses proprietary alloys for casting, ensuring the engine block is both strong and light enough to maximize performance. Once the metal has cooled and solidified, the block is sent to a machining center. At this stage, the block undergoes various processes like boring, honing, and grinding to meet exact specifications. Pistons, crankshafts, and camshafts are produced from forged steel and machined to tolerances as tight as a fraction of a millimeter. This high level of precision is necessary because the engine must handle extremely high pressures and temperatures. Once the components are ready, the assembly process begins. Technicians install the pistons, camshafts, and crankshaft into the engine block. The timing of the engine is set with exact precision to ensure that fuel injection and piston movement are synchronized perfectly. After the internal components are in place, the engine's external systems, such as turbochargers, fuel injectors, and cooling systems, are installed. Before being installed in a D11, every engine is tested on a dynamometer to ensure it delivers the power, torque, and reliability that Caterpillar promises. The dynamometer simulates real-world working conditions, pushing the engine to its limits. If the engine passes all tests, it moves to the next phase: installation in the D11. The D11's ability to move and operate its blade and ripper depends on its hydraulic system and transmission. These systems are critical for the bulldozer's functionality, and they are built with the same attention to detail as the engine. The D11 is equipped with a planetary power shift transmission, which allows the machine to smoothly shift gears while under load. This is essential when the bulldozer is pushing tons of earth. The transmission is assembled using gears, clutches, and bearings, all of which are machined to exact tolerances. After assembly, the transmission undergoes tests to ensure it can handle the massive torque generated by the engine. The hydraulic system is responsible for controlling the D11's blade and ripper, allowing it to raise, lower, tilt, and angle these components with precision. Hydraulics are essential to the machine's functionality, as they provide the power needed to manipulate such large pieces of equipment. Hydraulic pumps, cylinders, and hoses are built and assembled in a controlled environment to prevent contamination. The hydraulic system is tested under pressure to ensure it functions flawlessly. Each hydraulic line is carefully routed to protect it from damage, while ensuring that it can supply ample force to the blade and ripper. The blade and ripper are the most recognizable parts of the D11, and they are made to handle the toughest earth-moving tasks. The blade, which is mounted at the front, is responsible for pushing earth, while the ripper, mounted at the rear, is used to break up hard ground and rock. The blade is constructed from high-strength, wear-resistant steel, as it must endure constant contact with abrasive materials. Caterpillar uses robotic welders to fuse the steel plates that form the blade, ensuring a perfect weld every time. The curvature of the blade is carefully designed to maximize the amount of material it can push while minimizing resistance. After welding, the blade undergoes heat treatment to harden the steel, extending its lifespan. The ripper is forged from ultra-durable steel and features replaceable teeth. Each tooth is designed to penetrate the hardest materials, such as shale or compacted clay. The ripper frame and teeth undergo rigorous testing, including stress tests that simulate extreme working conditions. Caterpillar uses special alloys and heat treatments to ensure the ripper teeth can withstand tremendous forces without breaking or wearing out prematurely. The cab of the D11 is where the operator controls all the functions of the machine. It is designed for maximum comfort and safety, as operators often spend long hours behind the controls. Caterpillar equips the cab with ergonomic seats, air conditioning, and advanced control systems, including joysticks and touchscreens that make operating the D11 easier and more precise. Caterpillar understands that operator comfort is critical for productivity. The cab is mounted on shock-absorbing rubber mounts to reduce vibrations and noise. It is also equipped with large windows to provide excellent visibility, which is crucial when working with such a large machine. Safety features like rollover protection and fire suppression systems are built into the cab to protect the operator in case of emergencies. The D11 is equipped with Caterpillar's latest technology, such as GPS systems for precise grading and autonomous tractor systems, ATS, that allow the machine to be operated remotely or even autonomously in certain applications. This not only increases efficiency, but also keeps operators safe in dangerous environments, like mines or demolition sites. Once all the components are built and tested, the final assembly process begins. This takes place on a massive assembly line, where cranes and robotic arms lift and place components like the engine, transmission, and cab onto the mainframe. The D11's tracks are assembled and installed during this phase. The tracks, made from heavy-duty steel links, are built to withstand the immense weight of the machine while providing traction on all types of terrain. The tension of the tracks is carefully adjusted to ensure smooth movement. The electrical systems are installed last, connecting everything from the engine to the operator's controls. Technicians run extensive diagnostics to ensure that all systems communicate properly and that there are no faults. Once the D11 is fully assembled, it undergoes rigorous testing. Every system is tested under working conditions to ensure that the machine meets Caterpillar's high standards for performance, durability, and safety. The bulldozer is driven through test courses, and the blade, ripper, and hydraulic systems are operated to ensure everything functions perfectly. The Caterpillar D11 is not just a machine. It is a flagship product that showcases Caterpillar's engineering prowess and innovation. Its creation is a testament to the company's commitment to building the most durable, powerful, and efficient machines on the market. The D11 has become an invaluable asset to industries such as mining, construction, and oil exploration, where its ability to move massive amounts of earth and rock saves time and labor costs. By continually improving the D11 through advancements in technology, materials, and design, Caterpillar has maintained its leadership position in the heavy machinery market. The D11's ability to handle the toughest jobs ensures that Caterpillar remains the go-to manufacturer for large-scale earth-moving equipment. It not only enhances the company's reputation, but also contributes significantly to its revenue, making the D11 a cornerstone of Caterpillar's success. Thanks for watching. If you enjoyed this video, hit that like button and subscribe for more epic heavy machinery action. Don't miss our next video. Check out this recommended video right here. See you in the next one.